Okay, guys, we're gonna talk about rhombuses and squares, and they're like cousins, or tios, or tias, or uncles, or aunts of they're relatives of the squares. I mean the rectangles, guys. So now the cool thing about this, guys, is this: the only difference according to the theorems, if you look at the properties, not only are the sides equal to each other, they can be bent and everything if you want. Um, they also these diagonals right there are perpendicular, meaning that where they meet will be 90 degrees. That's the huge difference here. So here as well, I mean, you can see it in the square. A square is a parallelogram, and it's also rhombus. If you can just turn it around, it would be like a rhombus right there. So if you were to go here, if you were to actually do a line here, that's a huge difference. If you were to go here, there, because these sides are the same, then you have the right. See those? That's the huge difference here, guys. Okay, and I hope you can see it. If you go to the lesson here, you will be able to see that. So let's go to example one, guys, so you can see how that works. And so if let me see if I can do this real quick. If I was to snip this just real quick, so you can just for my sake, so I can make it a little bit bigger. Okay. Okay. So here, guys, if LM, I'm going to make it that orange right there. If LM, this side is 2x minus 9, and Kn is x plus 15, okay, then you need to say, well, hold on. If LM is congruent to Kn, of course, by the same token. So therefore, LM is equal to Kn, okay? Therefore, 2x minus 9 is equal to x plus 15, okay? And of course, then you say, oh my gosh, that's all I got to do is solve it, of course. So you just say, okay, I got 2x. Let's see if I can get that. 2x minus 9 is equal to x plus 15. You find the little baby. The little baby is x. So you're going to go to x and say, okay, baby, let's subtract both sides by 1x right there. So I got x minus 9 equals to 15. I'm going to add 9 to both sides. And if I do that, I'm going to get 24. Okay. So if they really wanted you to know what that side was like, if they ask you, you will just add, like right here, you will come over here and say, well, that's 2 times 24. This will be 48 minus 9. Then you will know that's 39. See that? This side will be 39. And here you will just add 24 plus 15. That will be 39. See? Check, 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 check. And that's one way of doing it. With that in mind, you can come here and say, well, hey, we got this. That was no problem. And let's try a little check problem right there. So in here, let me, if we were to do the same thing here, they're going to ask us to find a whole bunch of stuff here and a little check. And basically, the reason I'm doing this, guys, is because it's the same concept. As long as you know and you remember, so let me see. As long as you remember that that the difference here is that this is 90 degrees. 90 degrees. That's a huge difference. And everything else is congruent, 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 congruent. And of course, the lines are also congruent as well, I mean, the transversals, that we call that, or diagonal lines right there. So if zy is 22, this distance, and the angle w y and z. So this angle right here, guys, this angle is 35 degrees. They want you to find the whole information, the other one, okay? And that's not bad, guys. We can do it. We can do it. Hold on. We can do it. We can do it. See it? And let me show you how to do that. You can say, well, everything here is 22, right, guys? By definition. Okay? Everything is 22 there. What else do we know? Well, the lines We don't know much about the lines, but if this is 35, this is 90, right, guys? So to find this side right there, it will be 180 degrees minus 90 degrees minus 35 degrees, which is just 180 degrees minus 125 degrees, which will give us 65 degrees here to any angle. So this is 65 degrees, right? Because 65, oh shoot, it's not even 65, it will be 55, right, guys? Yeah, 50. Is it? Let me see. 10 to 125. No, it's 65. 65. Let me see. Did I do this right? 180 was 90 minus 35. There will be negative 125 and 55. Oh, shoot. Yeah, it's got to be 55 degrees, guys. It's 55 degrees. Okay. So with that information, we can find everything out, right, guys? Let's look at XZ. XZ. Let me see. XZ. This right here. We really. Oh, I'm sorry. AZ. What was AZ? We never got AZ here. Let me see. AZ. I forgot to do the A. What is the A? A and Z. AZ. This right here, guys, we said it was 14. So therefore, this is 14 as well, right? Yep. So XZ. Let me see if we can find XZ. That would be 28, right, guys? And the angle X, let me see, where is it? Angle, let me see here. Let me see if I can get a yellow one for this one. Let me see, that will be X. I'm gonna follow XY. So I'm gonna go XY right there. And then Z. What is Z? Right there. Okay, so they're trying to find out what is this angle right here. Okay. Well, you know, if this is because this is a diagonal right there, this will also be 35. And of course, that one will be 55 over there. So this whole thing will be 70 degrees, 35. Okay. Now let's try a different one. Let me see. What's the other angle? Okay, the other angle is going to be W. W. So we said W. X. So it's W X. I want to go Z, and then X Z. Okay, this one. This angle. What is that angle right there? And when you say, well, this if that's 90, and let me see, that's a transversal from here to that would be the I think this will be 55 degrees. Okay. I think that will be 55 degrees because you'll have, oh no, sorry. XYZ, it will be 35 degrees too. Sorry about that. I don't know what I'm thinking, guys. Let me see if I can go back over here. They want to know this small angle, and of course it will be, this one, the big one will be 55. Can you see that? Because that's 55 and 35. So therefore this has to be 35 degrees. Okay, 35 degrees. And there you are. The key here is to understand, guys, that this one is got 90 degrees and everything else is the same all the way across. And I think that's really, really interesting. And you do fine, guys. Thank you so much.